Okay, this is the electric load center video. We are on the east side of the breakfast nook. This is the powers coming in below grade. Our meter box should have been sealed on 3 sides to help prevent moisture infiltration into the wall. Also on our main load center, service panel, breaker box, call it what you will, it should also have been sealed on 3 sides to help prevent moisture from getting in through the bricks. When L1 and L2 come in here in those nice long leads, do you think somebody can get shocked on that? I do. You're supposed to have a non-conductive protective cover over these leads when they come into the panel. They could have done it with insulation. They could have done it with a non-conductive cover. They could have done it with something. This is the main neutral coming in to the system. It should be wrapped with white tape. If you don't know that's the main neutral, you don't belong in this box. I get that, but it should be wrapped with a minimum of 4 wraps of white tape, and not just 4 in one spot, but 4 wraps. Coming along here, we learned that we've got a single ground. Alright, by today's standards, we'd have 2 grounds within 6 feet. Our bonding location has not been labeled inside of here. Coming on along, some of our wires come in direct contact with the panel cover. Okay, that could cause some that's shocking news right there. Alright, now the white, if you don't know that's hot, the white coming in, that should be wrapped with black tape. That should be wrapped with black tape. 40 amps, white. Where are we going to see white here in the future? We're going to see it at the condensing units. This is not labeled for condensing units. Everything else is labeled except the condensing units. This is white right here. That tells us that the condensing units are 40 amps and 40 amps. Our condensers are rated for 30 amps. So our condensers are overfused. This means our condensers, these breakers, will not trip in a timely manner, that the condensing units can continue to run in a critical condition because the breakers are oversized. Okay, then on our clothes dryer, it should be GFCI protected. And then on our range and our cooktop, our oven and our cooktop, we should have lockouts on these so we can turn them off, lock them, and go work on the equipment. We should have lockouts on these. That should be GFCI protected. These are oversized. We got white hots. Now, our neutrals. This is our ground bus bar. Alright, we see some of these are double lugged. You can do that because electricity only goes in the ground in an emergency situation. But over here on our neutrals, every time you turn a switch on, the energy comes out of here, turns the fan around, and comes back in here, it runs home, completes the circuit, everything is fine. You loosen this wire and it'll turn off. Loosen this wire, it'll turn off. You turn the switch off, it'll turn off. These wires, these points, actually could be, it would break the circuit. In essence, become a switch. So we're not supposed to double lug our neutrals in here, alright? Because they get hot and cold at different times, swell and shrink at different times, and they can work themselves loose. You're not supposed to double lug your neutrals. It's okay to double lug your grounds. So, and then over here, see where it says main? Okay, that's printing. See all this gibberish? It's handwriting. The code and the panel manufacturer both want printing to identify your circuit breakers. So what do we learn? Our circuit breakers are hand labeled. Our meter and our disconnect box should have been sealed. L1 and L2 should have been better protected. Our neutral should have been better grounded, identified. Our white hots should have been better identified. Our neutrals should not have been double lugged. We should have had lockouts on a couple of our breakers for the kitchen. We should have had GFCI for the clothes dryer. Our condensing units are overfused. Our bonding location is not labeled inside of the cabinet. The wires touch the cabinet cover.